morning, everybody. My name is Professor Abhijit Roy. So I am congratulating you in my first class here, all of you, as you have cracked a very vital examination and to appear here to complete your course of IMG, means Indian Medical Graduate, to serve the society. But these are all big terms. I am not going to such extent. Now the anatomy, the first platform, first geographical marker of the medical science. When you go to a new town, for example, in America or somewhere, you first explore yourself, the geography and other regions, so that you can work, you can live. And it is the anatomy is the basic geography of our medical science, so that you can know what is where. Now, again, these are again big terms. I am not going to now. That the practical terms. Why we read? Can you tell me? Can amra pochi? Supratim. Now he thoroughly examined, thoroughly taking history, and the patient told, I have got blood in stool, and I have got some difficulty in passing stool. He examined the anal region and he found there is an ulcer. He took a biopsy and it is a cancer of the lower part of the rectum. Just patient comes with a pain, there is a swelling here. So missed it. What mind doesn't know, eyes cannot feel. And he diagnosed. Opposite may be there. So that is like the importance of knowing the lymphatic drainage of our anatomy. Look, simple swelling in your family, you diagnose and go without taking proper history, without having knowledge, and you go that, and you will be in big trouble, and there might be a Consumer Protection Act case against you. Dangerous. So that you have to learn and you have to apply. So time is short, already 10 minutes. So already you know what is lymphatics. Just 5 minutes.
Hey.
Go. You know, we have got heart pumps blood throughout the body, oxygenated blood. And it goes to the tissues, cells in distal part, and some of the and it filtered by the blood wall and plasma with some important nutrients, glucose, some dissolved gases, oxygen, and other nutrients, amino acids, etc., goes out in between the spaces of the cells, and the cells takes these things, use them for his factory, you use oxygen for respiration, cellular respiration, use glucose for metabolism, etc. And ultimately it produces something, for example, carbon dioxide and other products, it comes out. And it is go to the venous system. To the venous system. So blood comes out and to the venous system and ultimately goes back to the heart again. This is the normal. But something happened. For example, tissues produce some products which are molecular weight or volume is much larger. It cannot enter the venous system. It gets accumulated in this space. Because it cannot enter, its diameter is larger, its molecular weight is larger. Not only that, in our intestine, we absorb, we take food broken down into amino acids, glucose, and fats, fatty acids and glycerol. And fat cannot go, as you know already, soap is a type of fat, it is not mixed with water. So this fat cannot go with the blood. So it requires some other agent so that it forms a larger compound known as a mycin. MICELA, mycel. Because fat is insoluble in water, it cannot go through the blood. So these mycelium are larger. It cannot enter the venous system. So that what's happened? It will again remain in the tissue spaces. But if it is a remain in the tissue spaces, cannot go to the venous channel, there will be accumulation of substance. So that nature developed another system except in the brain and central nervous system. There is a no lymphatic system in the brain and CNS. And some say in the bone marrow also. Otherwise, everywhere the lymphatic system is present. And in between the lymphatic, this is the one function of the lymphatic system, a part function, to carry the nutrients ultimately to the heart. But the another function is very, very important. Can you tell me what is the another function of lymphatic system? Yes, producing lymphocytes, you can say lymphatic system, all right. So, immunity, resistance power, our resistance power. Because when there are some openings in our body, through the mouth, through the nose, etc. So that the external products, virus, bacteria, etc. goes inside. It must, and there are some barriers in our, but sometimes these are so cunning. ওরা এত চালাক, ওরা ওই ব্যারিয়ারকে ক্রস করে ঢুকে যায় ব্লাডে। So if it is not checked, this will produce disastrous effect in our body. So that nature gives and power to the lymphatic system, that is the immunity. Lymphocytes are present there and they can kill some foreign substances. They can modify some of the foreign substances. And so this is another function of the lymphatic system. So look, these are nothing, eta kirokom lagje? These are nothing but look like a train line. If you give a drone picture from the train lines look like that. Taito? Huh? Key? Yes. And in train lines, there are some stations. Some larger station, some small station. Similarly, this lymphatic system has got some stations. And some of these stations we are called lymph nodes. We are called lymph nodes. There are some unnamed lymph nodes. And specifically in our body, in certain region, there are some lymph nodes are assembled একসাথে থেকে একটা particular জায়গায়, in a particular area the assembled lymph nodes are there and we give them a name. For example, here, you know, this area is known as the axilla. We call it, there are some lymph nodes, multiple lymph nodes are there, we call them axillary lymph nodes. Here some lymph nodes are there, we call cervical lymph nodes. Similarly here, some lymph nodes are here, we call it inguinal lymph nodes because this area is the inguinal region, right? তাহলে এই আইডিয়া গেল, আর বেশি যেতে পারছি না বিকজ অরিজিনাল ডিসকাশন। সো look this picture, a beautiful picture. Ultimately small lymph vessels join together to form a large vessel, and these large vessel ultimately drain into a larger vein, so that ultimately even these substances, even the fat ultimately go to the blood. But you can ask me যে ব্লাডে গেলে তো সেই একই ব্যাপার হবে, ফ্যাট তো কি করে যাবে? No. Before going this picture, there is another substance, another organ is there. This is known as the liver. The liver modifies this fat and transform into fatty acid and glycerol. These are soluble. যাকে এগুলি পরে তোমরা পড়বে। So I'm going to the next. So these are the lymphatic system. These are the lymph nodes having idea. Now another question. These lymph nodes or lymph stations are present everywhere, agei bolechi, except in the brain, central nervous system and bone marrow. Now question arises, these are located everywhere, but for purpose of description, we divide them into superficial and deep lymph nodes, or the lymph vessels which are present close to the surface, we call superficial lymphatics. These are present deeper part, deep মানে কি ভেতরে, যেমন পেটের মধ্যে, লিভারের কাছে বা হাতে আরো ডিপে, তাকে বলি আমরা ডিপ লিম্ফ্যাটিক্স, and nodes are present there, we call deep lymph nodes. But what's happened to this extremity, superior extremity and inferior extremity? If you cut the skin of the superior extremity, if you cut the skin of the superior extremity by a scalpel and keep flap the aside, you will find a loose, a woolly structure we call superficial fascia. Some small nerves, small vessels and small lymphatic vessels are also there, present in the superficial fascia. If you remove the superficial fascia and keep them aside, then you find a mojar moto, there is a deep surrounding this extremity. We call it deep fascia. Tight, tough, deep fascia. If you cut the deep fascia, then you will find the muscles, some larger blood vessels, some larger lymphatic vessels, and ultimately most central part, মধ্যিখানে থাকে bones. So any veins, any lymphatic system, lymph vessels, lymph nodes present in the superficial fascia means superficial deep সম্বন্ধে idea হয়েছে তো, superficial to the deep fascia. If you cut the skin, you find the structures. We call it superficial lymphatic vessels and superficial lymph nodes. And the lymph nodes and the lymph vessels present deep, যেটা আমরা deep fascia কাটলে পরে দেখতে পাবো. When you cut the deep fascia, we will see the lymphatic vessels. We call deep lymph nodes and deep lymphatic vessels. আইডিয়াটা ক্লিয়ার হয়েছে? এবার আসলটা এবার যাচ্ছি। তাহলে আমরা জানি না, আমরা এই 15 মিনিট প্রায় চলে গেল, 20 মিনিট, যে আমরা জানলাম there are some lymph vessels are there, some lymph nodes are there. These are present, some of the lymph nodes are present superficially and some present deep. So lymphatic drainage of the inferior extremity, lymphatic drainage of the inferior extremity and deep lymphatic system superficial lymphatic system consists of lymph vessels and lymph nodes. আইডিয়া হয়েছে তো? এটা বুঝতে পারছো তো? হ্যাঁ, দেখা যায় না, রিফ্লেকশন হচ্ছে। আচ্ছা ঠিক আছে, এখানেই বলছি, ঠিক আছে, এখানে স্লাইডে আছে। তার মানে কি, আমি মুখেই বলছি। সো তোমাদের ব্ল্যাক অ্যান্ড ইটস রিকোয়ার্ড দ্য হোয়াইট blackboard and chalk duster is the best because whiteboard is not a good. আচ্ছা, তাহলে কি হলো? আমরা superficial lymphatics consist of lymph vessels and lymph nodes. ডিপ লিম্ফ্যাটিক্স, ডিপ ভেসেলস আর লিম্ফ নোডস। তার মধ্যে আমরা অত কিছু পড়বো না, আগেই বলেছি পরীক্ষার জন্য পড়া, শুধু লিম্ফ নোডস আমরা পড়বো। লিম্ফ নোড কোথায় কোথায় থাকে, বিকজ দ্যাট ইজ ক্লিনিক্যালি ইম্পর্টেন্ট। তাহলে আমরা বলতে পারি lymph nodes of the inferior extremity can be divided into superficial lymph nodes and deep lymph nodes. বলতে পারি lymph vesselsটা ছেড়ে দিলাম। So lymph nodes of the inferior extremity divided into superficial lymph nodes and a deep lymph nodes. And superficial lymph nodes of the lymphatic inferior extremity means only one, that is the superficial inguinal lymph nodes. So lymphatics of the inferior extremity has got a superficial inguinal lymph nodes and deep lymph nodes. একটা একটা করে যাই এবারে। superficial inguinal lymph nodes, এটার নামটা দেখে what we can learn, these lymph nodes are present in the superficial fascia, means superficial to the deep fascia. Why they are called inguinal? Because this region known as the inguinal region, there is a ligament here, from here to here a strong ligament is there, we call the inguinal ligament. These lymph nodes are present below the inguinal ligament and parallel to the inguinal ligament. এইবারে বুঝতে পারছো, দেখতে পাচ্ছ তো? বাস, তাহলে সুপারফিশিয়াল লিম্ফ নোডস ঝামেলার কিছু নেই। সুপারফিশিয়াল লিম্ফ নোডস অফ দ্য ইনফেরিয়র এক্সট্রিম এন্ড, সুপারফিশিয়াল ইনগুইনাল লিম্ফ নোডস। কিন্তু ডিপের ক্ষেত্রে ঝামেলা আছে। ডিপের ক্ষেত্রে দেয়ার আর টু, in some book it is written in three: deep inguinal lymph nodes and popliteal lymph nodes. And আরেকটা লিখে রাখো ওখানে অ্যারো দিয়ে, anterior tibial lymph node, এখানে দুটো দিয়েছি, আরেকটা লিখে রাখো anterior tibial lymph node. These are known as the deep lymph nodes. এবার যদি তোমাকে, আগেই বলেছি পরীক্ষা, এ শর্ট নোট কাম inguinal lymph nodes, তাহলে কি শুধু এটা লিখে চলে যাব নাকি এটাকে ইনক্লুড করব? হ্যাঁ, সাপোজ এ শর্ট নোট কাম inguinal lymph nodes, তখন কোনটা লিখব? হ্যাঁ, দুটোই লিখতে হবে, সুপারফিশিয়াল লিম্ফ নোড অ্যান্ড ডিপ লিম্ফ নোড। তখন কিন্তু পপলিটাল লিম্ফ নোডটা লিখব না। ক্লিয়ার হচ্ছে জিনিসটা না মাথা ঘুরছে একটু? তাহলে superficial lymph nodes in the inferior extremity present means the superficial inguinal lymph nodes, and deep lymph nodes consist of a deep inguinal lymph nodes and a lymph nodes present here, mainly known as the popliteal lymph nodes. হলো? এবার পরীক্ষায় কিভাবে লিখবে? অনেক জ্ঞান, তো পরীক্ষায় যদি এরকম ভাবে লিখতে পারো নম্বর পাবে। তার আগে ছবিটা দেখো। In this here, this is the arrangement of the superficial inguinal lymph nodes present in the superficial fascia. এবার একটু তাড়াতাড়ি যাব। কি অনেকটা, it is a T-shaped. It is a T-shaped. টির কি আছে? একটা হরাইজন্টাল লিম্ফ অ্যান্ড এ ভার্টিক্যাল লিম্ফ। দেখো এরও একটা হরাইজন্টাল লিম্ফ রয়েছে, একটা ভার্টিক্যাল লিম্ফ রয়েছে। তাহলে এটার নাম দিচ্ছি আমরা, অ্যানাটমির কাজই হচ্ছে শুধু নাম দিয়ে দিই। আপার হরাইজন্টাল গ্রুপ অফ সুপারফিশিয়াল লিম্ফ নোড, আর এটাকে আমরা নাম দিলাম লোয়ার ভার্টিক্যাল গ্রুপ অফ সুপারফিশিয়াল ইনগুইনাল লিম্ফ নোড। তাহলে সুপারফিশিয়াল ইনগুইনাল লিম্ফ নোড টার্ম ইম্পর্টেন্ট। সুপারফিশিয়াল ইনগুইনাল লিম্ফ নোড again divided into two strata. One is the upper horizontal group and lower vertical group. Upper horizontal group and a lower vertical group. Upper horizontal group, lower vertical group. Why they are called horizontal group? Because it is present horizontally. And it is parallel and below the inguinal ligament, present where? In the superficial fascia. Again, this upper horizontal group, look, divided into two parts. Some lymph nodes are present, this is the lateral side, this is the medial side. Some present laterally, we call lateral member of the upper horizontal group, and some present medially. Some present medially. These are called the medial member of the upper horizontal group. Important, very important. কেন আসছি সেইটা আসছি, আর এইটার কোনো ডিভিশন নেই, লোয়ার ভার্টিক্যাল গ্রুপ, রাইট? তাহলে এইটা গেল। এরপরে আমি কিভাবে পরীক্ষায় লিখবো, এইভাবে লিখবে, গল্প লিখবে না, পয়েন্ট ওয়াইজ লিখবে, নম্বর বেশি উঠবে। হ্যাঁ, এটার সাথে অনেক স্লাইড আছে, আমি তাহলে কাট করে দেব, একসাথে অনেকগুলি। সিচুয়েশন ক্লাস স্লাইড দিলে তো আর ক্লাসেই আসবে না। Is superficial fascia in the upper anterior part of thigh, below and parallel to the inguinal ligament, along termination of the great saphenous vein. GSV মানে great saphenous vein বা long saphenous vein. এটা দুটো লিখলাম কেন? একটা হচ্ছে ওপরটা হচ্ছে আপার হরিজন্টাল গ্রুপ, প্রেজেন্ট parallel to the inguinal ligament, and lower vertical group present along the near the termination of the great saphenous vein. Number, total number 9 to 12. 9টা থেকে 12টা lymph node থাকে total. Distribution, upper horizontal 5 to 6, lateral and medial, and lower vertical, which is present along the termination of the great saphenous vein, 4 to 5 in number. হলো? এই দেখো, এটা হচ্ছে অরিজিনাল লিম্ফ নোডস, ইয়ে। এবার তোমরা বলবে এটা কি গ্রুপ, একজন বলো। হ্যাঁ, টোটাল কমপ্লিট, ইয়েস, আপার হরিজন্টাল গ্রুপ। আর এইটা কাট, এইটা কি তাহলে? গ্রেট সেভেন। এইটা কি সাদাটা? ডিপ ফাসা। দেখতে পাচ্ছ ডিপ ফাসার ওপরে রয়েছে। এবার ক্লিয়ার হচ্ছে? তাহলে টোটালটা হচ্ছে সুপারফিশিয়াল ইঙ্গুনাল লিম্ফ নোড, আর এইগুলি হচ্ছে লিম্ফ ভেসেলস ড্রেন করছে নানা রকম লিম্ফ নোডে। এটাও কি? একটু তাড়াতাড়ি করো, টাইম চলে আসছে, আরো পড়তে হবে, অনেক কিছু বাকি। আপার হরিজন্টাল গ্রুপ, এটা হচ্ছে ল্যাটারাল গ্রুপ, এটা হচ্ছে মিডিয়াল গ্রুপ, এটা হচ্ছে লোয়ার ভার্টিক্যাল গ্রুপ। এইটা কি ওপেনিং? স্যাফেনাস ওপেনিং, ক্লোজড বাই ক্রিব্রিফর্ম ফাসা। নর্মালি এরকম ফুটো থাকে না, ক্লোজ থাকে। এটা কি গ্রুপ? আপার হরিজন্টাল। যদি বলি এইটুকুনিটা কি গ্রুপ? ল্যাটারাল মেম্বার অফ, ভেরি গুড। আপার, তো ওইখানেই তো পড়া হয়ে যাচ্ছে তোমাদের, আমার থেকে ভালো মনে রাখতে পারছো। আমি দেখবে গুলিয়ে যাব একটু পরে। এটা লোয়ার ভার্টিক্যাল গ্রুপ গেল। এইবারে তোমাদের লাস্ট যেটা আসল ক্লিনিক্যালি ইম্পর্টেন্স, এটা এত কিছু শিখলাম কেন? তার কারণ হচ্ছে এই লিম্ফ নোডস আর দ্য মার্কার অফ এ ডিজিজ, especially infection and cancer. এই যে গ্রেট টো, সেখানে যদি কোনো ক্যান্সার হয় বা ইনফেকশন হয়, দিস ইনফেক্টিভ, আগেই বলেছি ইনফেকশন ইজ চ্যালেঞ্জড বাই দ্য লিম্ফ নোডস, বাই দ্য লিম্ফ্যাটিক lymphocytes which are present in the lymph nodes. যে ক্যান্সারাস সেল, সে সবসময়, they always try to spread, the infective material, they also taken up by the blood veins and try to spread. And some of the infective material and the cancer cells also taken up by the lymphatic vessels. And they also try to go through the lymphatic system, ultimately go to the venous system so that it can affect the whole of the body. But these are challenged by some stations known as the lymph node. These are challenged, try to stop by the lymph nodes. So, যখন fight হচ্ছে between the bacteria and virus or infective material, Staphylococcus aureus, a bacteria, there occurs fight in the lymph nodes. And there, in the fight, they are produced some inflammatory material to combat these bacteria. More lymphocytes, more interleukins and other substance, swelling occurs, and ultimately these lymph nodes are swelled. The lymph nodes are swollen, বড় হয়ে যায়। যদি ইনফেকশন থাকে, these lymph nodes may be tender, মানে কি টিপলে ব্যথা লাগবে। আর যদি ক্যান্সার হয়, it may be stony hard, বড় শুধু হবে না, like a stone it will feel. Normally lymph nodes are rubbery in consistency, but if cancer, it is stony hard, মানে একদম এরকম শক্ত হয়ে যাবে, ফিল করলেই বুঝতে পারবে। So this is the beauty of our finger. So you can diagnose without going to some investigation procedure. Suppose there is a cancer in the superficial part of the squamous cell carcinoma of the great toe. Skin cancer হয়েছে, superficial. Ultimately দেখা পেশেন্ট তো জুতো পরে এসেছে, তুমি দেখলে এই জায়গাটা একটা সোয়েলিং রয়েছে, খুব একটা ব্যথা নেই, বাট স্টোনি হার্ড, তখন বলবে দেখি তোমার জুতোটা খুলুন বা পাটা দেখি, then you can diagnose it. So you have to know the draining area. A station, Bardhaman station must know from where the train is coming. So these are known as the afferent. And the train, after stopping in the Bardhaman, go to other stations, and these train we call the efferent. So A for apple. Afferent means something coming towards that particular thing. Efferent, E for eagle, something going out. So through the afferent, we can know the pathological area where this infection comes. So what are the afferents of the upper lateral group? এখানে ছবি আঁকা যাবে না, দেখতেও পাবে। আপার ল্যাটারাল গ্রুপের অ্যাফারেন্ট কোথায়? আপার ল্যাটারাল এই জায়গাটায় ভালো করে লক্ষ্য করো, ইনফিরিয়র এক্সট্রিমিটি অলমোস্ট নেই তোমার। তাহলে একটা শিখলে দেখো, অলমোস্ট ইনফিরিয়র এক্সট্রিমিটির কোনো জায়গা থেকে কিন্তু অ্যাফারেন্ট বা ইনফেকশন হলো এখানে আসছে না, এক্সেপ্ট গ্লুটিয়াল বা ব্যাক রিজিয়ন। তাহলে অ্যাফারেন্টগুলি জানতে হবে কোথার থেকে আসছে। বাবা, নাম্বার 1, আপার ল্যাটারাল গ্রুপের অ্যাফারেন্ট কোথায় যাচ্ছে? ফ্রম দ্য গ্লুটিয়াল রিজিয়ন অফ দ্য সুপারফিশিয়াল। আমি কিন্তু কি ডিল করছি? সুপারফিশিয়াল লিম্ফ নোডস। সো গ্লুটিয়াল রিজিয়নের মাসেলস থেকে এখানে যাবে না। স্কিন, সাবকিউটেনিয়াস টিস্যু, সুপারফিশিয়াল ফাসায় যদি কিছু হয়, স্কিনে যদি ক্যান্সার হয়, সুপারফিশিয়াল ফাসায় যদি কিছু হয়, ইনফেকশন হয়, অ্যাবসেস হয়, ফোড়া হয়, দেন দিস আপার ল্যাটারাল গ্রুপ ইজ ইনভলভ, বড় সুপারফিশিয়াল ইঙ্গুনাল লিম্ফ নোডস উইল বি ইনভলভ। বুঝতে পেরেছো? মাসেলসের যদি কিছু হয় অন্যখানে যাবে, কোথায় যাবে পরে আসছে। তাহলে এখানে সব কিছু কিন্তু গ্লুটিয়াল রিজিয়ন মানে টোটাল গ্লুটিয়াল, মানে মাসেলগুলি বলছি না, সুপারফিশিয়াল রিজিয়ন অফ দ্য গ্লুটিয়াল রিজিয়ন। গ্লুটিয়াল মানে কি? এই জায়গাটা। আর কি? লোয়ার পার্ট অফ দ্য ব্যাক অফ দ্য অ্যাবডোমেন বিলো দ্য আম্বেলিক্যাল নাইন, এই জায়গাটাকে বলে ফ্ল্যাঙ্ক। এই যে আমার কোমর ভালো করে দেখতে পাচ্ছ, এই জায়গাটাকে বলে ফ্ল্যাঙ্ক, এই যে ফ্ল্যাঙ্ক, অ্যান্ড এই জায়গাটা ব্যাক। এই আম্বেলিকাস থেকে যদি একটা হরিজন্টাল প্লেন টানো, তার নিচে যদি কিছু হয়, ইফ দেয়ার ইজ এন সামথিং ইনফেকশন অর ক্যান্সার ইন দ্য স্কিন below the umbilical plane, but not in the anterior side, but on the posterior side, it will goes to the lateral group of superficial inguinal lymph nodes. বুঝতে পারছো? আর কি, আপার পার্ট অফ দ্য ল্যাটারাল সাইড অফ থাই, এইটুকুনি, মানে এই পেছন থেকে যেটা যাচ্ছে ল্যাটারাল গ্রুপ। তাহলে 1 2 3 এটা লিখে নাও। Afferent, number 1 gluteal region, upper part of the lateral side of the thigh, flank and back of the abdominal wall below the umbilical plane. Back. তাহলে তুমি যদি একটা পেশেন্টের এখানে লিম্ফ নোড হয়েছে, তুমি ওপর দিয়ে দেখে করলে পেছনটা দেখলে না, ওখানেই একটা ফারাঙ্কল বা ফোড়া হয়ে রয়েছে, তুমিও ট্রিটমেন্ট করলে না, পেশেন্ট বলতে ভুলে গেছে, বাচ্চা ছেলে বলতে বলেনি, সেটা মাথায় রাখতে হবে। নেক্সট স্লাইড যাচ্ছি। আচ্ছা, আমি এটা দিয়ে দেবো, এটা আমি দিয়ে দেবো তোমাদের, একজনকেও আমার সাথে শেয়ার করবেন, দিয়ে দেবো, লিখে রাখো। এইবারে দেখো, খুব ইম্পর্টেন্ট এটা। এবার মিডিয়াল গ্রুপ অফ দ্য আপার ল্যাটারাল, এটাও ইম্পর্টেন্ট, ভেরি ইম্পর্টেন্ট, ভালো করে পড়লেই বুঝতে পারবে, পড়তে থাকো। সাবকিউটেনিয়াস টিস্যু অফ দ্য অ্যাবডোমিনাল ওয়াল বিলো দ্য আম্বিলিকাস, এইখানে if there is an infection or cancer in the skin and subcutaneous tissue, it will go to the medial group of superficial inguinal lymph node, upper horizontal group. আর কোথায়? পেনিস and prepuce. আমরা জানি পেনিসের এটা তো পার্মানেন্ট মার্কার, এটা দিয়ে লিখলে তো নষ্ট হয়ে যাবে, এটা দিয়ে কেউ লেখাবে না, এটা দিয়ে ডেঞ্জারাস, তার জন্যই বোর্ডটা নষ্ট হয়ে গেছে। এটা পার্মানেন্ট মার্কার, দূরে সরিয়ে রাখো। আমরা যদি পেনিসটাকে দেখি, দেখবো দেয়ার আর 3 টিউবস হেয়ার, এবং এইটা হচ্ছে বডি অফ দ্য পেনিস বলি, এটা হচ্ছে স্কিন, এটাকে বলি বডি অফ দ্য পেনিস, আর এইটার নাম দিয়েছি গ্ল্যান্স পেনিস, আর এই স্কিনটাকে বলা হয় প্রিপিউস। এবার দেখতে পাচ্ছ তো এই কালারে, এইটাকে বলা হয় প্রিপিউস। এই আপার মিডিয়াল গ্রুপে যাচ্ছে পেনিস, এই টোটাল পেনিসটা প্লাস প্রিপিউস, এই স্কিনটা, কিন্তু এই জায়গাটা যাবে না, এখানকার লিম্ফ নোডস অন্যখানে ড্রেন করবে। তাহলে কি লিখেছি? পেনিস ইনক্লুডিং দ্য প্রিপিউস অ্যান্ড স্ক্রোটাম অ্যান্ড অলসো দ্য স্ক্রোটাম। আমরা জানি এইটা হচ্ছে স্ক্রোটাম, আর এইটা কি? টেস্টিস, যেখানে স্পার্ম উৎপাদন হয়, স্পার্মাটোজোয়া ডেভেলপ। কেমন? তাহলে পেনিস অ্যান্ড স্ক্রোটাম গোজ টু দ্য, সরি এইদিকে যাবে, গোজ টু দ্য আপার মিডিয়াল গ্রুপ অফ সুপারফিশিয়াল লিম্ফ নোডস। এবার যে এক্সাম্পল, হোয়াট এক্সাম্পল আই হ্যাভ সেট ইন দ্য ফার্স্ট টাইম, লোয়ার পার্ট অফ দ্য অ্যানাল ক্যানেল বিলো দ্য পেকটিনেট লাইন। কোথায় অ্যানাল ক্যানেল? দেখো এইখানে গেছে ইনভলভ হয়ে গেল। So if there is a cancer in the lower part of the anal canal below the pectinate line, there is a line, ছবি আছে দেখাচ্ছি, সেখানে কিন্তু পেশেন্ট কমপ্লেন করেনি, পেশেন্ট বলছে এইখানটায় সোয়েলিং, কিন্তু if you miss this, if you miss the rectal examination, anal examination, you will miss the cancer. ফার্স্ট সাইন এখানটাই বলেছে, পেশেন্ট ভাবছে একটু ব্লাড তো যেতেই পারে, আমার একটু ডিসেন্ট্রি হয়েছে, ও গুরুত্ব দেয়নি, it give not importance, there is some strain, some pain, oh normally I have got constipation so there is some pain, actually he is going to suffering from the stage 1 cancer. If you delay, it goes to the stage 2, stage 3. So if you know there is a lymph node and examine properly, you can diagnose and save a patient life, and also save yourself also. Next, Superolateral angle of the uterus along the round ligament of the uterus. কোথায় দেখো uterus so deeper structure, তার superior পার্ট থেকে lymph nodes এই মিডিয়াল গ্রুপ অফ আসছে, ওইখানে একটা কিছু হয়েছে, এইখানটায় হচ্ছে। সুতরাং দিস আর দ্য ইম্পর্টেন্স অফ নোয়িং দিস। আগেই বলেছি শুধু পরীক্ষায় নয়, এটা তোমাকে লাইফ সেভ করে দেবে কোনো দিন যখন ইউ গোয়িং টু প্র্যাকটিস। সো দিস আর দ্য অ্যাফারেন্স টু দ্য আপার মিডিয়াল গ্রুপ অফ সুপারফিশিয়াল ইঙ্গুনাল লিম্ফ নোডস। বুঝতে পেরেছো? এবং পরীক্ষায় তো ইম্পর্টেন্স বুঝতেই পারছো, মনে রাখতে হচ্ছে। এই যে কোন, এবার একটু জায়গাটাকে দেখাই। ও বাবা, এটা হচ্ছে ফ্ল্যাঙ্ক, গ্লুটিয়াল রিজিয়ন, এই যে স্ক্রোটাম, এই যে পেনিস, এটা হচ্ছে গ্ল্যান্স পেনিস। এই যে রেকটাম অ্যানাল ক্যানেলটাকে কেটেছে এই পার্টটা, এই যে লাইন, এই যেখানে একটা লাইনের মতো আরবিট্রারি, তাকে বলা হয় পেকটিনেট লাইন। এইখানে যদি ক্যান্সার হয় এটা চলে যাবে তোমার মিডিয়াল গ্রুপ অফ সুপারফিশিয়াল ইঙ্গুনাল লিম্ফ নোডস। আবার এইখানে যদি ক্যান্সার হয় সে পেটের ভেতরে চলে যাবে ইলিয়াক গ্রুপ অফ লিম্ফ নোডস। তাহলে ইম্পর্টেন্স। আর ভালভা অ্যান্ড ভ্যাজাইনা ইন কেস অফ এ ফিমেল, লোয়ার পার্ট অফ দ্য ভালভা অ্যান্ড ভ্যাজাইনা, সেও আপার মিডিয়াল গ্রুপ অফ লিম্ফ নোডসে যাবে। এই যে দেখতে পাচ্ছ, লোয়ার পার্ট অফ ভালভা ভ্যাজাইনা থেকে আপার মিডিয়াল গ্রুপে যাচ্ছে। এবার ওখান থেকে কোথায় যায়? এটা তো গেল স্টেশনে, ট্রেন এলো, বার্ডওয়ানে দেয়ার আর ট্রেন কামিং ইন ফ্রম হোয়ার, ফ্রম বার্ডওয়ান হোয়ার টু গো? হাওড়া। সিমিলারলি all the superficial inguinal lymph nodes pierce the cribriform fossa and drain into deep inguinal lymph nodes. Ultimately চলে গেল deep inguinal lymph nodes, and deep inguinal lymph nodes থেকে চলে যাবে external iliac lymph nodes, ওখান থেকে ultimately thoracic duct হয়ে বেরিয়ে যাবে, ভেনে চলে যাবে। এরপরে আমরা সুপারফিশিয়ালটা শেষ হয়ে গেল, আর লোয়ার ভার্টিক্যাল গ্রুপটা আচ্ছা, লোয়ার ভার্টিক্যাল গ্রুপ অফ সুপারফিশিয়াল ইঙ্গুনাল লিম্ফ নোডসটা কোথায় ড্রেন করে, কি অ্যাফারেন্ট কি আছে? লোয়ার ভার্টিক্যাল গ্রুপ অফ সুপারফিশিয়াল ইঙ্গুনাল লিম্ফ নোডস ড্রেন, এবার ভালো করে শোনো, এটা লেখা নেই স্লাইডে, মিস হয়ে গেছে। ড্রেন দ্য সুপারফিশিয়াল লিম্ফ্যাটিক্স অফ দ্য ইনফিরিয়ার এক্সট্রিমিটি থাই except the area which are shorts, which are except the area present in the region of the short saphenous vein, means lateral part of the leg. কালকে তো শর্ট স্যাফেনাস ভেইন পড়েছো তো, হ্যাঁ? গ্রেট স্যাফেনাস ভেইন, শর্ট স্যাফেনাস ভেইন। গ্রেট স্যাফেনাস ভেইন এই বিশাল ভেইন এখানে ড্রেন করছে, আর পেছন দিকে এখান দিয়ে এসে এই ছোট্ট ভেইনটাকে বলা হয় শর্ট স্যাফেনাস ভেইন। এই শর্ট স্যাফেনাস ভেইন ড্রেন করে কোন এলাকা? ল্যাটারাল পার্ট অফ দ্য লেগ, ল্যাটারাল হাফ অফ দ্য পস্টেরিয়র পার্ট অফ দ্য লেগ, অ্যান্ড দ্য ল্যাটারাল সাইড অফ দ্য অ্যাঙ্কেল অ্যান্ড ল্যাটারাল সাইড অফ দ্য ফুট। এই এলাকাটুকু বাদ দিয়ে বাকি সমস্ত এরিয়া ড্রেন বাই দ্য গ্রেট স্যাফেনাস ভেইন। সিমিলারলি খুব ভালো করে শোনো, এটা পরীক্ষায় ভাইভাতে জিজ্ঞেস করবে। The lower vertical group of superficial inguinal lymph nodes afferents come from, আচ্ছা লেখো, তা আসতে বললে তার 10 মিনিট আছে। সুপারফিশিয়াল lower vertical group of superficial inguinal lymph nodes drain the inferior extremity, superficial lymphatics, সবসময় superficial lymphatics of the inferior extremity, except the lateral part of the leg, the lateral part of the leg, এই যে leg দেখাচ্ছি তো, lateral part of the leg lateral half of the posterior part of the leg বা posterior part of the leg, lateral part of the ankle, lateral means এই সাইডটা, lateral part of the ankle and lateral part of the foot. ব্র্যাকেটে লেখো এরিয়া অফ শর্ট স্যাফেনাস ভেইন, এক কথাই হয়ে যাবে। তাহলে তোমার গ্রেট টোতে যদি একটা ইনফেকশন হয় সে চলে যাবে ভার্টিক্যাল গ্রুপ অফ ইঙ্গুনাল লিম্ফ নোডস, কিন্তু লিটল টোতে যদি ইনফেকশন হয় তাহলে কিন্তু ওখানে যাবে না, কোথায় যাবে আসছি। তাহলে এইটা হয়ে গেল সুপারফিশিয়াল ইঙ্গুনাল লিম্ফ নোডস। এবার ডিপ লিম্ফ নোডস 5 মিনিটে শেষ করব। ডিপ ইঙ্গুনাল লিম্ফ নোডস, medial side of the upper part of the femoral vein, most proximal or upper node lies in the femoral canal. তোমরা femoral sheath পড়বে, femoral তখনই জেনে যাবে what is femoral canal, কেমন? and তার একটা নাম আছে, glands of Rosenmuller or glands of Cloquet. A uppermost group of the deep inguinal lymph node, uppermost group এই সরি uppermost member গ্রুপ কি বলছি, ভুল বলেছি, সরি। এই যে ডিপ লিম্ফ নোডস, এটা হচ্ছে ফিমোরাল ভেইন, এর মিডিয়াল সাইডে এই এরকম লিম্ফ নোড আছে। ডিপ মানে ডিপ টু দ্য ডিপ ফাসা, ফিমোরাল ভেইন ইজ এ ডিপ স্ট্রাকচার, তাকে আমরা নাম দিয়েছি ডিপ ইঙ্গুনাল লিম্ফ নোডস। ডোন্ট কনফিউজ উইথ দ্য সুপারফিশিয়াল ইঙ্গুনাল লিম্ফ নোডস। সুপারফিশিয়াল ইঙ্গুনাল নোডস ইজ parallel to the upper part of the great saphenous vein, and deep inguinal lymph nodes is parallel to the upper part of the medial side of the femoral vein, which is a deep structure. And uppermost part, এই গ্ল্যান্ডটাকে একটা স্পেশাল নাম দেওয়া হয়েছে গ্ল্যান্ডস অফ ক্লোকেট or গ্ল্যান্ডস অফ রোজানমুলার। ইট অ্যাকচুয়ালি ড্রেইন দ্য, ওই যে বলেছিলাম গ্ল্যান্ডস পেনিস or glans clitoris. ফলে এইখানে যদি কোনো ক্যান্সার হয় এই গ্ল্যান্ডস অফ ক্লোকেট উইল বি এনলার্জড। বুঝতে পেরেছো? ডিপ মিস করে যেতে পারি, ডিপ লিম্ফ নোড সবসময় প্যালপেট করা যায় না, মিস হয়ে যেতে পারে। তাহলে পেনিসের সব পেনিস সুপারফিশিয়াল গ্রুপ, গ্ল্যান্ডস অফ পেনিস ডিপ গ্রুপ, মনে থাকবে। পেনিস superficial group, glans penis deep group. Similarly, scrotum superficial groups, testis এটা কিন্তু চলে যায় অ্যাবডোমেনের ভেতরে, ইনসাইড দ্য অ্যাবডোমেন অ্যাওর্টার পাশে একটা গ্ল্যান্ড থাকে, প্রি অ্যাওর্টিক অ্যান্ড প্যারা অ্যাওর্টিক লিম্ফ নোডস। টেস্টিস ড্রেইন ইনটু প্যারা অ্যাওর্টিক লিম্ফ নোডস। যাকে ছেড়ে দাও। এই যে ডিপ লিম্ফ নোডস প্যারালাল টু দ্য ফিমোরাল ভেইন, এর এই যে ফিমোরাল ক্যানেল, এইটা হচ্ছে লিম্ফ নোড অফ দ্য ক্লোকেট। আচ্ছা, পপলিটিয়াল লিম্ফ নোডস এইখানটায় থাকে ইন দ্য এই জায়গাটার নাম হচ্ছে পপলিটিয়াল ফসা, ডিপ 3 to 4 in number, popliteal lymph nodes along the termination of the short saphenous vein draining into the popliteal vein. ওই জায়গাটাতে popliteal lymph nodes থাকে। It drains the deeper structures of the leg and also superficial lymphatics, যেটা বাদ দিয়েছিলাম গ্রেট স্যাফেনাস ভেইনে, lateral side of the leg, posterior part of the leg, lateral side of the ankle and lateral side of the foot. তাহলে এটার ইউনিক কি ফিচার এই popliteal lymph nodes এর? It drains both the superficial and deep lymphatics. Superficial inguinal lymph nodes only drain the superficial lymphatics, but the popliteal lymph nodes not only drain the deeper structures of the leg, but also the superficial structure of the lateral side of the leg, lateral side of the ankle, etc. So popliteal lymph nodes drain both superficial and deep lymph nodes of the lateral part of the leg plus deeper structure of the whole leg. Popliteal lymph nodes থেকে ultimately কোথায় যায় efferent? Goes to the femoral lymph nodes. femoral কি? Deep inguinal lymph nodes. হয়ে গেল? তাহলে afferents to deep inguinal lymph nodes কি হলো? Deep inguinal lymph nodes যেটা along the femoral vessels থাকে, এবার রিক্যাপিচুলেট করো। Superficial inguinal lymph nodes, popliteal lymph nodes, glands penis or clitoris, deep lymphatics of the lower limb accompanying femoral vessels. Efferent কোথা থেকে যাচ্ছে? ডিপ ইঙ্গুনাল লিম্ফ নোডস থেকে। মুখস্থ করে নাও এখন, এক্সটার্নাল ইলিয়াক লিম্ফ নোডস পেটের পেলভিসে রয়েছে ভেতরে। এটা আপাতত জাস্ট ক্র্যাম করে নাও, মুখস্থ করে নাও। নি জয়েন্ট থেকে লিম্ফ্যাটিক্স ড্রেন করে কিন্তু and there are some inconstant node present in the anterior on the medial border of the tibia, deeper part তাকে বলে anterior tibial lymph node। ছেড়ে দাও। এবার তো এটা বলছি, যখন any swelling of the lymph node we call lymphadenopathy. So if there is a swelling in the inguinal lymph node we call inguinal lymphadenopathy. Lymph মানে lymph, adeno means gland, pathy means disease, lymphadenopathy। এই দেখো আরেকটা জিনিস, এলিফ্যান্টিয়াসিস বাংলায় বলে গোদ, কিছুই নয়, লিম্ফ্যাটিক ভেসেলস ইজ ব্লকড বাই এ মাইক্রোফাইলেরিয়া, ফাইলেরিয়াল প্যারাসাইটস, সো দ্যাট lymph cannot go upside. They are blocked. They present in the tissue spaces, ultimately stimulates some of the cells to produce huge swelling. We call it elephantiasis. এই মশা থেকে হয় উচেরিয়া ব্যানক্রফটি, এই যে ফাইলেরিয়াল প্যারাসাইট। তাহলে মোটামুটি আইডিয়া হলো। তাহলে এবার যদি বলি, একটু শর্ট করে নিচ্ছি, লিম্ফ্যাটিক ড্রেনেজ অফ দ্য ইনফিরিয়ার এক্সট্রিমিটি, তাহলে কিভাবে লিখবে? সুপারফিশিয়াল lymphatics and deep lymphatics. Superficial lymphatics, all of the superficial lymphatics drain into the lower vertical group of superficial inguinal lymph nodes except lateral part of the leg, lateral part of the lateral half of the posterior part of the leg, lateral border of the foot and lateral part of the ankle, right? গেল। তাহলে ওগুলি কোথায় ড্রেন করছে? ইনটু দ্য পপ্লিটিয়াল লিম্ফ নোডস। তাহলে সুপারফিশিয়াল লিম্ফ নোডসকে আমরা দুটো ভাগে ভাগ করতে পারি। সুপারফিশিয়াল লিম্ফ্যাটিক্স অফ দ্য, এইখানে সুপারফিশিয়াল লিম্ফ্যাটিক্স হোল অফ দ্য থাই গোজ টু, কোথায় যাবে? যে সুপারফিশিয়াল, এটা কোথায় যাবে? লোয়ার ভার্টিক্যাল গ্রুপ অফ সুপারফিশিয়াল ইঙ্গুইনাল লিম্ফ নোডস। ল্যাটারালে যদি হয় স্কিনে, কোথায় যাবে? পপ্লিটিয়াল গ্রুপ অফ লিম্ফ নোডস। আর ডিপার লিম্ফ্যাটিক্স কোথায় যাচ্ছে? ইন দ্য থাই especially goes to the deep inguinal lymph nodes, and in the leg it goes to the popliteal lymph nodes, from the popliteal lymph nodes it goes to the inguinal lymph nodes. বাস, তাহলে ক্লিয়ার হলো। আর কি ক্লিনিক্যাল অ্যাপ্লিকেশন জানবো? একটা হচ্ছে লিম্ফ্যাডেনোপ্যাথি কাকে বলে, ওরালে জিজ্ঞেস করবে। ফাইলেরিয়াসিস কি, ওটাই কেন এরকম হয়? ডিউ টু ব্লকেজ অফ দ্য লিম্ফ্যাটিক ভেসেলস বাই দ্য উচেরিডিয়া ব্যানক্রফটি, এ মাইক্রোফাইলেরিয়াল প্যারাসাইট। শেষ। তার লিম্ফ্যাটিক ভেসেল শেষ হয়ে গেল, সুপারফিশিয়াল ইঙ্গুইনাল লিম্ফ শেষ হলো। এবার আশা করি তোমাদের ক্যান্সার লোয়ার পার্ট অফ দ্য অ্যানাল ক্যানেল মিস হবে না। এখান থেকে আশা করি সারা জীবন মনে রাখবে এই জিনিসগুলি, যে একটা ভালভাই ক্যান্সার হলে কোথায় ইঙ্গুইনাল লিম্ফ নোড হয়, আবার লোয়ার পার্ট অফ দ্য ব্যাকে যদি হয় তাহলে ল্যাটারাল পার্ট অফ দ্য ইঙ্গুইনাল লিম্ফ নোডস হবে। সুতরাং ইঙ্গুইনাল লিম্ফ নোডস হলো একটা সোয়েলিং এলো আর তুমি একটা অ্যান্টিবায়োটিক লিখে প্লিজ ছেড়ে দিও না। প্লিজ গো ইনফরমেশন, ফিল দ্য অ্যাবডোমেন, ফিল দ্য অ্যানাল ক্যানেল, এটসেট্রা। Thank you very much.
This we completed yesterday, and it has come to our the 7th class. It's called translocases. It's called translocases. So the 7th class translocases are a group of enzymes which do not contribute to any molecular change of the molecule, but or structural change or change by formula, but they just dislocate, translocate, you transfer one molecule from one side of the membrane to the other side of the membrane. Okay, so these enzymes are called translocases. Now, coming to the next question, the nomenclature of enzymes. Nomenclature or naming of enzymes. Enzymes which were initially started being named as per their substrate on which they act on. Say, maltase act on maltose, isomaltase acts on isomaltose, etc., etc. Later on, they found that many enzymes have got similar activity, but they act on different substances, like proteases. Right? Like, for example, trypsin. Trypsin can act on protein from many sources. So, it was a requirement at the time that they should come up with a new naming system. Then they formed International Union for Biochemists, IUB. They formed a commission called Enzyme Commission, which stands EC here. Enzyme Commission. They formed this commission and they formulated a special nomenclature formula. How to name them? They gave 4 digits. The first digit will designate the major class, that is one of those 1 to 7. Okay. Second digit will denote, if suppose this is a transferase, then which molecule is being transferred. 2 means transferase. So, what type of molecule they will transfer. If it is number 1, then it is oxyreductase. Then whether it is accepting hydrogen or accepting oxygen, depending on that different subtypes. Okay. Then third digit comes subtype. Who is giving that electron? Suppose he is receiving an electron, so who is giving that electron? Correct? Who is giving that particular phosphate group? Is it inorganic phosphate or organic phosphate? Free phosphate or bound phosphate? Sulfate? Who is giving the sulfur group? So, or depending on these, they gave a subtype or subclass. The fourth digit designate only the sequence of the discovery. Suppose this enzyme is the first to be discovered under this class. Which class? 2, 7, 1 and 1. So, subtype 1, under this subtype, this is the first enzyme to be discovered or named. Okay. So, whenever anywhere in the world any person come up with a new discovery of enzyme, they must answer these questions. Which major class they fall in, 1 to 7. Depending on that, they will put this one, and then this come subclass, whether they are taking phosphate, giving sulfur, taking something else, giving something else. That portion they have to define. From which compound they are taking, that portion they are defining the subclass. Correct? And then lastly, this fourth digit will be given by enzyme commission. First 3 digit, whoever will discover the enzyme, they have to determine and inform to the commission. The fourth digit will be given by the enzyme commission itself. Okay. So, for example, there is an enzyme EC1111. What is the enzyme? Alcohol dehydrogenase. Okay. Similarly, so this is the first enzyme to be discovered or named, not discovered but named according to this nomenclature. So, this is a short question, nomenclature of enzyme you will get, classification of enzyme you will get, properties of enzyme you will get. All these will get as a small short question. Classification of enzyme also is very, very important. All right, just go through it. All right. So see, this is a name actually to be given to the enzyme, scientific name, but we call it hexokinase. So this is scientific name, and this is থার্ড এটা, ইয়েস। তো এখানে যেমন মনে করো এই যে সাব ক্লাসে ফসফেট গ্রুপটাতে তো ও ট্রান্সফার করছে ফসফেট গ্রুপটা, এবার ফসফেট গ্রুপ ট্রান্সফার করছে কার থেকে, কাকে, কার থেকে ফসফেট গ্রুপ ট্রান্সফার করবে সেটা মোটামুটি ফিক্সড, মনে করো অর্গানিক ফসফেট বা ইনঅর্গানিক ফসফেট, সেখানে ক্লাসিফিকেশন অতটা ডিফার করবে না। কিন্তু কাকে দিচ্ছে, অ্যালডিহাইডকে দিচ্ছে, অ্যালকোহলকে দিচ্ছে, অ্যাসিডকে দিচ্ছে, তাই না, এর উপর ডিপেন্ড করবে। সেই হিসেবে অ্যালকোহলকে যদি দেয় তাহলে সেটাকে সাব ক্লাস 1 ডিনোট করা হয়েছে। এরকম একটা পদ্ধতি ওরা তৈরি করেছে আর কি। এগুলি ডিটেলস খুব একটা আসে না, তাই তোমাদের এই একটা যে কোনো একটা এক্সাম্পল মনে রাখলেই চলবে। আর যেটা বলছিলাম হেক্সোকাইনেস, এই নামটা কি, এই ধরনের নামটা বলা ট্রিভিয়াল নেম, মানে ডাক নাম, তাই না। আর এইটা হচ্ছে ওই তুমি যদি IUPAC করো তাহলে এরকম নাম হবে। আর এটা হচ্ছে এনজাইম কমিশনে দেওয়া ডিজিট। এবার আসি অ্যাক্টিভ সাইট। ভেরি অফেন দিস শর্ট কোশ্চেন কামস। ডিফাইন অ্যাক্টিভ সাইট, give its features, and describe the processes by which active site can be determined. কিরম বলবে অ্যাক্টিভ সাইট বলতে আমরা বুঝি the portion or region of the enzyme or the domain of the enzyme which actually interact with the substrate. Correct? So active site actually holds comparatively very small region of the whole enzyme molecule. So actually তুমি ধরো যে আমি এই পেনটা দিয়ে লিখতে চাই, তো আমার কি দরকার হয়, অ্যাটলিস্ট 2 বা 3টে আঙুল, বাকি আঙুলগুলো আমার দরকার নেই, তাই না। কিন্তু তার যদি তুমি হাতটা এখান থেকে কেটে দাও তাহলে আঙুলটা লিখতে পারবে না। সো অ্যাক্টিভ সাইট যত ছোটই হোক না কেন, however small area it comprises of the whole enzyme molecule, the total structure of the enzyme molecule is very, very important. You know? Because all other muscles of this palm will control the movement of these 3 fingers. Correct? So if the muscles are not there, they will not be arranged in a proper way. They cannot hold the pen. It will slip off. Correct? So that's why the rest of the regions is also very, very important to maintain the small active site area of the enzyme. Now this active site has got some specific shape due to tertiary structure of the protein. Now protein in the 4 layers or orders of protein structure you have studied: primary, secondary, tertiary and quaternary. Quaternary structure is not available in all the proteins unless they are multimeric proteins. So tertiary structure, up to tertiary structure, all the proteins will have the tertiary structure that is fixed. So the tertiary structure and secondary structure. Can you tell me the difference? White shirt. The structure, the function of a protein is a function of its structure. Ki bollam? Can you repeat? The function of a protein is a function of its structure. Can we repeat one more time? So it is the structure on which the function of the protein depends. It may be enzyme, it may not be enzyme, but every protein has got some function. You agree or not? Correct? Bosu. Now, the primary structure designates nothing. It's an imaginary structure where we imagine that all the amino acids present in the polypeptide chain exist in a straight line, one after another from N-terminal to C-terminal, joined by peptide linkages. So it is just the way of expression of component amino acid residues in a polypeptide in a piece of paper, on a piece of paper by writing, that's all. Alanine, glycine, cysteine, threonine, methionine, etc., etc. That is primary structure. So it just gives the actual number where the amino acid is located in the peptide structure. That's all. It does not give any structural insight. It gives compositional insight. Am I clear? Coming to secondary structure. Secondary structure is a special arrangement of polypeptide backbone. Can you repeat? So polypeptide backbone may have different kinds of structure. It may be spiral, will be called alpha helix. It may be triple helix. It may be corrugated like beta sheets. It may be beta bands. Correct? It may be uneven. Kunta. Secondary structure is a special arrangement of polypeptide backbone. Hello? So all these different types of special arrangement of polypeptide backbone give rise to different type of structure, and all are three-dimensional structure. Spiral, alpha helix, ribbons. They are not so regular in structure like alpha helix, but they are also spiral. We call them ribbons. Ribbons, chule fite? Ribbons or ribbons? है ना? 310 helix. Now, tertiary structure. So the secondary structure means special arrangement of polypeptide backbone. Tertiary structure means structure forms different structural units. Right? Now, in a given protein, any number of secondary structural units may be present. Do you agree or not? A portion of it might be alpha helix, a portion of it might be beta band, a portion might be ribbon, a portion of it might be beta sheet. All together will form a complete protein. Now, how they are arranged with against each other. Say, for example, this is one alpha helix, this is one alpha helix. Okay, they might be like this, they might be like this, they might be like this, they might be like this. All are three-dimensional arrangements. Correct? But they're different. This is tertiary structure. So tertiary structure is defined by the spatial arrangement of secondary structural units. Simple. Secondary structure is spatial arrangement of correct, and tertiary structure is secondary. How those alpha helix are actually located with the beta sheet. Right? This is beta sheet, this is alpha helix, like this. They might be like this, they might be like this, they might be like this. Right? Like this, any side it might go. So these arrangement are described by tertiary structure. That's why it is very difficult to describe tertiary structure. Right? Because it is totally three-dimensional. Same like this one also, secondary structure, but it is simpler than tertiary structure. So here, when I say the enzyme active site has a specific shape due to tertiary structure, is it clear now? Correct? Now suppose there is a distance between two alpha helices about 0.2 micron or Armstrong. Due to some changes in the primary structure, some amino acid is changed, this distance is increased due to repulsion. Correct? So primary structure can give rise to alteration in secondary structure as well as tertiary structure as well as quaternary structure if it is so. Correct? So primary structure is very, very important. Fine. But that must be in an area which is responsible for that particular function. Do you follow? Now suppose I am holding the pen. If I apply glue here, then my hand will stick to the pen. If I apply glue here, this portion is also required for the movement of the finger, as I mentioned earlier. But if I apply glue here, that will not alter any movement. Am I right? So that is why the change in the primary structure, if it takes place not at the active site, it will not bring about any changes. So that is why sometimes we can remove in some cases a major portion of the enzyme and keep the active portion only. Keep the active portion only which is required for our function. Can I give one example? There is a DNA polymerase used for in vitro DNA synthesis. Okay? So that DNA polymerase is actually an artificial product formed by cleaving a portion which is not required. A DNA polymerase has got three regions, three enzymatic activity. One, polymerization, one 3' to 5' proofreading, and another is 5' to 3' proofreading activity. So 5' to 3' proofreading activity is not required. We remove it because it will slow down the process. We keep the 3' to 5' process. So these together they form a separate artificially produced DNA polymerase which is used for DNA synthesis in vitro artificially at higher rate compared to the native DNA polymerase. Like this. So without changing the active site, we can change the other portion of the protein. Now a change in the shape of the protein alters the function and efficiency of active site. Sickle cell anemia. Now what is active site actually? Active site is made up of these two. This fingers we have. So all these 4 fingers are necessary for holding the pen, but not for writing the pen. If these 2 fingers are not there, then what will happen? There will be a gap on the paper. My pen, I have to put extra effort to keep the pen straight. There are many people who has lost these 2 fingers. They can write, but they have to give extra effort so that this movement will be restricted. Now these 2 fingers are actually those binding sites, and these 3 fingers are catalytic sites. Okay? The active site, within the active site, there is a small region where the substrate actually interacts with the portion of the enzyme. It's called substrate binding site. Within the substrate binding site, there are few, 1 or 2 or 3 amino acid residues which actually participate in the chemical reaction. Those regions is called catalytic site. So for example, trypsin, chymotrypsin, these proteases are called serine proteases. If you are not writing the examples, you will forget afterwards. Just make this habit of writing while listening the lecture. Serine proteases. The serine, why they are called serine proteases? Because their catalytic site contains serine residue. Now, if you mutate serine residue, what will happen? This will not function as protease. If you block the serine residue, how? There is a compound called DIPF, diisopropyl phosphofluoridate. DIPF, diisopropyl phosphofluoridate. If you want to inhibit serine proteases irreversibly, means which cannot be reverted back to normal state, then you can apply DIPF and it will be completely forever inhibited. How? This DIPF will go and react with serine and form a covalent linkage. Remember, if the enzyme must hold the substrate tightly, but if it holds very tightly, what will happen? Our parents must love us very much, love you, your parents, very much. But if they love so much that they will never allow you to climb down out of their lap, will you be able to learn how to walk, how to run, how to go to school? But there is no doubt that they love you so much. So too much of love is not required. Sometimes some repulsion is required. So enzyme substrate interaction is very, very interesting. They hold it very specifically, very tightly, but at the same time, not so tight that even after the reaction is over, the product will not be able to go out of the active site. They should be very specific. At the same time, they should be allowing the product to leave the space. Otherwise, how you will grow up? How you will come here and study MBBS? Suppose you love your parents love you so much that they don't want to allow you to go out. They will arrange a medical college inside your house. Is it possible? No. It's like that. So sometimes, holding something is not important. How you are holding it, that is important. Whether you are able to leave it when it is necessary or not, that is important. Right? So, catalytic site performs a catalytic activity. Now, these are the three processes by which we can determine active site of an enzyme. Till few years back, this was a very favorite question for university. Nowadays, they have shifted. For last 2 years, this question has not arrived. But suppose this comes, then you should be able to answer it. I have mentioned here three processes by which you can find out the active site. Three procedures. Each procedure can be elaborated in any electronic medium, YouTube or any book you can see. But I will give you the basic idea of these three procedures, how they actually approach. So that whenever you go further, you understand on your own. Because these three are the techniques which are very difficult and very elaborate topics. This will eat most of the time of the class. That I don't want. The first one is use of specific inhibitor. If we want to identify the particular active site of an enzyme, we have to find out what is the inhibitor of that enzyme. How? How do you find inhibitor? Simple trial and error method. I did not ask you the definition of inhibitor. Sit down. Simple trial and error method. Okay, they go on adding different substances. They find after giving this, enzymatic activity decreases. So this is inhibitor. After giving substance B, enzymatic activity further decreases. So B is better inhibitor than A. Correct? Now after giving the inhibitor, when they freeze it or separate the enzyme, which portion of the enzyme is actually functional, we can make out. How? We freeze the protein at the very moment when the enzyme is bound with the inhibitor. Correct? The moment the inhibitor binds with the enzyme, we take a photograph of this. But how to take the photograph? First of all, we have to, how we can take a photograph. If I keep walking like this, can you take my photograph? You can take my video, but not photograph. Right? What first thing is necessary is to stand still. So how to make them stand still? By freezing. So lower the temperature, they freeze. They cling to each other, wherever it was. Some molecules will be like this, some molecules will be like this. Any orientation, but some will be like this. bound with the inhibitor. We take the photography. We take the photography with the camera. But for molecules, this camera is not necessarily not useful. We need X-ray crystallography. What is this X-ray crystallography? Can anyone tell me? By using X-ray, it is clear. Crystals means whatever photograph we want to take, we have to make their crystals. How you make crystal? By lowering the temperature, freezing them. Done. So far is clear. Now, the X-ray. Suppose this is a molecule. Suppose this is a molecule. Now, you all know about the shape of this pen because we have already seen something like that in your life. You know how to use it also. You know how to misuse it also. Right? So if I ask you about what is a marker pen, what is the shape of marker pen, what will be the answer? If I ask you what is the shape of marker pen? Cylindrical. But just tell me what is the shape now? What is the shape now? Rectangular. How come you are telling this cylindrical? When you take my photograph, you get a very flat, thin person. Am I so? Then? You take a still photograph, two-dimensional way. So we are living in a three-dimensional world. We can express one dimension less in two dimension, not in three dimensional. Had I been in four-dimensional world, I could draw a three-dimensional diagram. Clear? Since you are not in four-dimensional, we are three-dimensional, we can express in two-dimensional. So X-ray structure, X-ray photos will come in two-dimensional. So this, how do you know this is cylindrical? This is very difficult. So in a mixture of this molecule, some molecules will face the X-ray like this, some molecule will face the X-ray like this, some this, like this, like this, like this, like this, in any possible direction and location. Clear? What we have to do? We have to take normal photograph after conceiving what could be its structure. Suppose we conceive that this is a cylindrical, we make a model like this with plaster of Paris or something like that, ball and stick model, and then we take photograph from all possible direction with normal black and white camera. Then all these photographs we mix, and we know that if this kind of diagram comes, the structure of the object is like this. So what they did, they prepared all possible models. They took photograph, kept those photographs beside the X-ray photograph of the molecules. Then they compared in which model maximum number of similar photographs have been obtained. From there, they found out that since all the photographs are matching with the X-ray photograph of this molecule like this, so the model of the molecule was like this. That's all. Very simple. That's why it took so many years to determine the structure of DNA. That is how they first had to think how could be the structure of DNA, then make the structure of the DNA model, and that's why you have seen in the photograph that those two Watson and Crick, they are standing on a ladder and showing this model in the photographs, DNA model, long model. So they made it. Then they took photograph. Then they compared the actual photographs with the X-ray photographs of this thing or radiographs of the DNA molecule. Then they came to this conclusion that since all the photographs are matching with this, the structure of DNA will be like this. That's why it was very difficult those days. So X-ray crystallography, by which we can measure, we can make out the actual structure of the active site. Means where there is upward bulging, where there is concave shape in the active site, everything we can make out by X-ray crystallography. Clear? Specificity of enzymes. Again, one important short question. You need to give examples. Absolute specificity. Glucokinase, specific for glucose only. No other carbohydrate, no other hexose sugar. Absolute specificity. Specific for a single and only that molecule. Clear? Group specificity. It is there are many molecules having a similar group, so that enzyme is specific for that particular group. Like alcohol dehydrogenase. It is specific for ethanol, methanol, propanol, isopropanol, etc. Correct? Whether you take ethanol, it will convert it to acetaldehyde, acetic acid. If you consume methanol, it will convert to formaldehyde, formic acid. Clear? With group specificity. Bond or linkage specificity. Yes, all proteases, they are bond specific. They are bond or linkage specific. Stereospecificity. Have you heard of R and S isomerism? So molecules are very specific. Suppose there are 3 methyl groups in a molecule, and the enzyme has to remove one methyl group. It might be very specific which methyl group to be taken. So for example, citrate. Citrate synthase. How it is formed? For citrate synthase, synthesize citrate, form acetyl-CoA and oxaloacetic acid. Correct? So this enzyme is highly specific, stereospecific about the formation of the citric acid. Geometric specificity. The bulkier group may be located on same side of the double bond or opposite side of the double bond. Depending on that, we have 2 geometric isomerism, cis and trans. Can they differ in their function with enzymes? Yes. All enzymes which oxidize fatty acids are trans fatty acid specific. Cis fatty acid they do not act on. Okay? Let's take it otherwise. The trans fatty acids actually, if they suppose cis and trans are there, the enzyme in beta oxidation, which metabolize this is the best example. The enzymes in beta oxidation, they act on delta 2 trans enoyl-CoA. Means if the bond is in trans configuration, then they can perform the reaction. If the bond is in cis configuration, they cannot. Clear? Delta 2 trans enoyl-CoA. Delta 2 means the one triangle and then power as a power 2. Delta 2 trans enoyl-CoA. They are trans fatty acid specific. Clear? Not cis fatty acid. If they are in cis position, we have to first convert it into trans and then the reaction have to take place. Done? Any question from here? Now this one has been omitted from your syllabus. This one has been omitted from your syllabus, but some portion is asked separately. Now, what I mentioned before last class was how enzymes act, means mechanism of enzyme action. And this is mechanism of catalysis, how enzymes actually catalyze the reaction. So there are 6 types. Acid-base catalysis, electrostatic catalysis, covalent catalysis, metal ion catalysis, proximity and orientation effect, and transition state stabilization theory. Obviously, this is the last one, or the latest one. So acid-base catalysis, in most of the reaction, either acid or base will participate as a reactant, correct? And oxidation and reduction will take place simultaneously, always. So someone will give away hydrogen ion, someone will accept it. The molecule which will give away hydrogen ion, it will be oxidized. It will be called base. The molecule which will take up the hydrogen ion will be called, which will give away the hydrogen ion will be called acid, and which will accept the hydrogen ion will be called base. So this kind of reaction where acceptance of hydrogen takes place is called acid hydrolysis. Where giving of hydrogen ion take place is called opposite. I am always telling opposite thing. Why it is happening? Yeah, the other way around actually. So it's called base catalysis. When we accept H plus ion, it's called base catalysis. When we give away H plus ion, it's called acid catalysis. Correct? And when these two take place simultaneously, we call acid base catalysis. Go through quickly. Since it is not asked in this way nowadays, so we will not spend more time. Just go through it, and if it is understood here in the classroom, better. Afterwards, you cannot understand it from anywhere. বাড়িতে পড়ে ভিডিও দেখে আর বোঝা হবে না, যদি বোঝা হয় এখানেই হবে, নাহলে হবে না। ডান? ওই জেনারেলটা মানে অ্যাসিড ক্যাটালিসিস বা জেনারেল অ্যাসিড ক্যাটালিসিস, জেনারেল বেস ক্যাটালিসিস একসঙ্গে করে দিলে অ্যাসিড বেস ক্যাটালিসিস। হলো? চেঞ্জ? See, some of the examples have been given. Glutamic acid, aspartic acid, proton donor, proton acceptor, glutamate and aspartate. When they are glutamate and aspartate form, they are proton acceptor. When they are glutamic acid or aspartic acid form, they are proton donor. Lysine, arginine, they have extra amino group. If there is RNase3 plus, then it is proton donor. If there are RNase2 dot, lone pair, that means deficient of electron. Not deficient of H plus ion. So they acceptor, they can accept H plus ion. So they becomes the same molecule, becomes general base. Okay, same molecule. Cysteine, RSH, RS minus. Histidine, imidazole ring without hydrogen. Serine, ROH, RO minus. Tyrosine, ROH, RO minus. Electrostatic catalysis. Electrostatic catalysis means, suppose there are many amino acids which are positively charged and there are other amino acids which are negatively charged. All basic amino acids are positively charged, all acidic amino acids are negatively charged. So when they come near each other, they have electrostatic interaction. They have electrostatic interaction. Now what is prerequisite for this particular reaction to take place? It should be, number one, in a very close vicinity, the distance between two molecules. Secondly, in between those molecules, there should not be any molecule of water. Why? Water is the best insulator. It will nullify the charge effect. It has highest dielectric constant. That's why for any reaction to take place, the active site should be water free unless it is hydrolase. Correct? So water should be removed so that they can, correct? They can interact positive with negative. If they're both positive, then they will repel. Both negative, they will repel. Positive, negative, they will attract. So this kind of interaction called electrostatic interaction. Covalent catalysis, when enzyme and substrate form covalent linkage. Covalent linkage. Phosphates. Some enzymes are active when they are phosphorylated. How? Covalent modification. Okay? So the covalent bond is necessary to hold that particular molecule very strongly. Electrostatic is less weak. Okay? Van der Waals force, weaker force. Hydrogen bond, weaker force. But covalent bond is strong. But electrostatic bond is stronger when they are more in numbers. Usually electrostatic interaction takes place when the molecules are more in number. And that's why the cumulative electrostatic force is much stronger than any force present. But individually, if you consider, the covalent bond is the strongest. Followed? So they might have serine proteases, say acyl serine intermediate, cysteine proteases, acyl cysteine intermediate, protein kinase and phosphatase. If you can just take a photograph, which will be helpful later on. Nucleophilic catalysis and electrophilic catalysis. The nucleophile or electrophile will be attached covalently. Nucleophile means positive lover. Electrophile means negative lover. Right? Fine? Now, coming to metal catalysis, this is very, very important. This you have to remember. This is very often this is asked, very often. Almost every year. Okay, two things will be asked from here. Difference between metal activated ions, enzymes and metalloenzymes and their structural features, and examples itself of different enzymes. So here metal ions, they participate in two ways. They might be structural component of the enzyme. In those cases, we will call it metalloenzyme. They might be required for the proper activity. Just for activity is required. We call them metal activated enzymes. Clear? Examples of metalloenzymes: carbonic anhydrase. Examples of metal activated enzyme: hexokinase, where magnesium ion is required. Correct? Now, what do they do actually? What do they do actually? They hold the water. See, for example, in carbonic anhydrase, the zinc hold the water molecule so that H2CO3 can be formed. So that water doesn't move here and there. So zinc's function of zinc molecule is to hold the water molecule in one place. Followed? For other purposes, where magnesium is used for hexokinase, they function like this. They shield the negative charge of beta and gamma phosphate so that of the ATP. Beta and ATP has 3 phosphate. This is ATP, adenosine. From here, 3 phosphates are there. This one is called alpha, this is beta, and this is gamma. The most away from the molecule is called gamma phosphate. Which phosphate is transferred to glucose? Gamma phosphate. G for go gamma. Fine. Now, the hexokinase molecule active site or substrate binding or catalytic site is located way inside the molecule. It's like a shark mouth. So the molecule has to go inside. The gamma phosphate must reach inside, very, very deep inside the molecule of the enzyme for the transfer of the gamma phosphate. And that is only possible when gamma phosphate is neutral in charge. Because it is charged, then it will be repelled by the other amino acid residues present inside. Correct? How to make it? The magnesium will shield the charge over beta and gamma phosphate. So that gamma phosphate can enter deeper till the active site or substrate binding site or catalytic site of hexokinase, where it will be acted on by the enzyme and phosphate will be removed and transferred to glucose. The molecule has to have places for not only gamma phosphate and beta phosphate, but also it must have place for magnesium ion and one glucose molecule. Correct? Instead of glucose, if you give any pentose sugar, the reaction will not take place. The phosphate will be hydrolyzed, but sugar phosphate will not be formed. Why? The 6 carbon position of the 6 carbons position of the hexose sugar will be occupied by water molecule. Water will not be excluded. The moment hexose sugar is given, water will be excluded. There is no water, the reaction will take place, glucose 6-phosphate will be formed. But instead, glucose, if you give ribose 5-phosphate will not be formed. But ATP will be hydrolyzed. The gamma phosphate will be removed, but ribose 5-phosphate will not be formed. Is it clear? So this is the action of magnesium is, you'll find in your book, in your small books, you'll find. Do a diagram, they have magnesium showing 2 lines on gamma phosphate and beta phosphate, shielding their charge. Shielding charge means neutralizing the negative charge over beta and gamma phosphate so that they become neutral and they can enter the deeper regions of the enzyme's active site. Clear? We'll stop here. We'll take, can we take, this is last class, na? 5 minutes, we'll finish this one. Proximity and orientation effect, yes. Proximity and orientation effect. If you read it, you won't understand. If I show you, you'll understand. है ना? Sure. ठीक है? दिखा जरा. दिखा जरा. Now, বাংলা বুঝছো? এই দুটো ওকে দে, তুই 2 অবধি নিবি, ঠিক আছে? ভেরি ইজি, নিয়ে নে, হ্যাঁ, হয়ে গেল, হ্যাঁ, ট্রান্সফার অফ মলিকুল, ফাইন, দিয়ে দে, পিছন ফের, ওই টাকা, এবার দে। What is the difference? Are they close enough? Yes, they are close enough. Proximity is there, but not the orientation. Proximity is there, but not orientation. Turn around. সরবি না দে নে চেষ্টা কর নাও orientation is there but not proximity, correct? So two molecules, ciao, thank you for your cooperation. So two molecules will not, so when I say the function of a protein is a function of its structure, I think now it is very clear to you. It is not only structure but their proximity, their orientation also necessary for the reaction to take place. Say SN1 reaction, they always, in case of SN1 reaction, SN2 reaction, the nucleophile is always attacked from behind. The nucleophile is always attacked from behind, okay? It is not from the face to face. Now take a photograph of this. This is important for this one, all metal ions and their corresponding enzymes. Very commonly this can be asked in MCQs. Last one, না এটা ওটা কোথায় গেল? Last one, ওই হ্যাঁ। Transition and stabilization. Transition state stabilization says the last theory of how enzymes act. How enzymes act. The active site is not exactly complementary to the native structure of the substrate. Rather, it is more complementary to the transition state of the substrate. How? Now, when we design inhibitors, if we design inhibitors in two types of designs, the one design, the inhibitors are made just exactly structurally similar to substrate, and in another process, inhibitors are made exactly structurally similar to the transition state structure of the substrate. Clear? When one inhibitor is made structurally similar to the substrate, in another inhibitor is made structurally similar to the transition state structure of the substrate. It was found in the reaction that section B molecules are more efficient than section A, means the molecules were made structurally similar to the transition state structure of the substrate, found to be more effective inhibitor than who are designed actually as a structurally similar to the native structure of the substrate. Now here the transition state is maintained by distortion of the structure. So suppose these two, if we force like this, then we distort it. But initially, normally they want to stay like this. When we press it against, we change in their shape, distortion. This requires some energy. It's called activity energy. Activity energy. Now this is required for the reaction to take place. The reaction will never take place on a substrate like this. This was a theory that distortion must take place in the substrate in order to convert it into transition state so that reaction can take place. Simple. That's all.
Already read about normal urine. Yes or no? Yes. Okay. So can anyone tell me what are the constituents of normal urine? Anyone? So major part of the urine is formed by what? Major, I am not asking what are the constituents, what are the things organic and inorganic that are present in urine. I am asking what is the major part of urine formed of? Water. So first water and then dissolved ingredients, and in it organic and inorganic. Okay. So these you have learned about the normal. So now today we will learn about some abnormal constituents of urine. So you have read about how urine is formed in class 11, 12, something about how urine is formed. So tell me the name of the organ which is mainly involved in the formation of urine. Kidney. Liver ke bollo? Kidney. So after kidney, in the kidney the urine is formed. So after kidney, the part through which the urine is excreted or given out from our body, that is called urinary tract. So what are the constituents of urinary tract? Ureter, urinary bladder, and then urethra. So first, this is the kidney. So kidney has two parts, medulla, that is the inner part, and cortex, that is the outer part. And then from here, this is the pelvis, renal pelvis. And from this renal pelvis, the ureter is coming out for draining the urine. So what is the functional unit of kidney? Nephron. So this is the structure of nephron. So here we can see, what is this structure? Glomerulus. That is the tuft of capillaries. Then outside the glomerulus, what is this structure? Bowman's capsule. From here, what is this thing? Proximal convoluted tubule. Then it forms the loop of Henle, and then distal convoluted tubule, which drains into the collecting duct. So here also, this is the glomerulus, Bowman's capsule, proximal convoluted tubule, loop of Henle, distal convoluted tubule, and collecting duct. So here the blood is coming in, and here the blood is going out. So it is getting filtered. So what are the things that will come inside this part? Glomerular filtrate. So what are the constituents that will be coming out? It is not, you cannot say this is plasma. The plasma is associated with blood. So as long as the blood is flowing through, so the plasma here, I said blood is coming out from this way. So the plasma along with the constituents, RBC, WBC, platelet, protein, they are going out here from this vessel. So water, you have to say water, sodium, potassium, amino acids, glucose, these are getting out into the Bowman's capsule. Okay. So I said amino acids, sodium, potassium, glucose, all are going out. But in normal urine, do you find all these four things? So which one do you don't find? I said four: sodium, potassium, amino acids, and glucose. Among these four, glucose you will not find in normal urine. Then amino acids, is it present or not in normal urine? Not present. Late cano. So this has to be, this glucose, some amount of sodium, amino acid, this has to be absorbed back, because urine does not contain glucose amino acids. So here in the proximal convoluted tubule, most of these things are getting absorbed. So in this picture you can see, in the proximal convoluted tubule, glucose, amino acids, sodium, a good part of water is going out into, what is this thing? Just outside this proximal convoluted tubule, loop of Henle and distal convoluted tubule, peritubular capillaries. So it is again coming into the blood. And then, so here the blood is getting filtered. Here there is some reabsorption of the important constituents of the blood. And then some things are again secreted back from the peritubular capillaries into the urine. So this is the secretion, tubular secretion. So now once the urine is formed, it will pass through the urinary tract and go out of our body. So why you perform this urine examination? So you can determine if the kidney is diseased or the kidney is healthy. You can also find out whether some other process like systemic illness. A very important disease is diabetes, in which you can find glucose in the urine. So there are two kinds of diabetes. One is diabetes mellitus and another is diabetes insipidus. So which one have glucose in urine? Mellitus. So you can find the condition of the kidney, some systemic diseases, or if there is any infection, any pathogen, bacteria or virus in the urinary tract, especially bacteria, you can diagnose. Either you can visualize the stained slide prepared from urine to see the bacteria under the microscope, or you can culture the urine so the bacteria will grow more and we can see. So there are physical characteristics of urine, chemical characteristics, microscopic appearance and culture to see the pathogens. So what are the physical characteristics of urine that we normally see? Color, then odor. So what is the normal color? Straw color or slight yellowish. Is it hazy or transparent? Normal urine, transparent. Then odor, it has a aromatic odor. Sometimes ammonical. Why? Air content. ওখান থেকে একটা বলছিলে। Exactly. So when urea is getting degraded, ammonia is coming out. So what is urea? Nitrogenous waste. So how it is formed? So during protein metabolism, ammonia is given out. So you will learn in detail how the amino acid is broken and they are liberating ammonia. So ammonia is utilized in which organ to produce urea? Liver, exactly. So color, odor, then pH. So what is the normal pH of urine? 6.5 to 6.8. But sometimes it is also, so it is acidic or basic? Normally it is acidic. But even in normal person, the pH can vary. It can vary from pH 5 to about 8 in a normal person. So when the pH is 8, is it acidic or basic? Basic. So can a normal person have basic urine? Yes, because I have already said it is from 5 to 8. So can any one of you tell me in which condition? Vegetarian diet. Any other condition? High protein diet, okay. Acidic, but even whatever you are eating, if you estimate the urine after eating, there is a phenomenon called alkaline tide. Anyone, have you heard of that? So everybody knows that in our stomach, there are some cells which secrete acid. So which acid is secreted in our stomach? HCl. From which cells? Oxantic cells. So when the stomach is secreting more acid, some bicarbonate ions are secreted back into the blood. So in physiology, you will learn how the acid is secreted into the stomach. But for now, just know that when the stomach is secreting acid into the stomach on the food, then it is also secreting the stomach, the cells, the oxantic cells are also secreting bicarbonate into the blood. So when there is more bicarbonate into the blood, it becomes acidic or basic? It becomes basic. So after meal, when the stomach is secreting more acid into the stomach, the bicarbonate is also increasing in the blood, and urine is produced from the blood. So after meal, the increased level of bicarbonate in the blood is called alkaline tide, as the alkali level is increasing. And this has to be excreted out from the body because the blood pH also has to be maintained. So do you know what is the normal pH of blood? 7.4. So this is the normal pH. Or you can say 7.35 to 7.45. That is the normal pH. So when there are more bicarbonate ions in the urine, it will become acidic or basic? It will become basic. So what after pH? Any other physical characteristics? Specific gravity. So what is the normal specific gravity? Any one? 1.01 to 1.025. Or sometimes you can also say 1.1 to 1.030. Like you have to be in a close range. Okay. Different books give around this value. Okay. So these are the physical characteristics. Anything else? More or less these are the physical characteristics. Then chemical, we will detect the abnormal constituents. So we will try to find out if the urine have amino acid, protein. So amino acids are making the protein. So whether the urine contains protein, glucose, ketone bodies. So do you know what are ketone bodies? Can you name any ketone body? So in the blood, we generally find 3 ketone bodies. Any idea about ketone bodies? In our diet, there are 3 kinds we generally take in our diet, not about ketone body. So one is carbohydrate, another is protein, another is fat. So these are the main ingredients of our food. So he said ketogenic diet. So in that diet, which thing should be more? Okay, leave out ketogenic diet. So that is different. That is related, but we don't want to discuss about that. So ketone bodies are generally produced from fat. So ketone bodies we can detect by a test called Rotheras test. So this one you will learn later. Today we will learn about how we can detect glucose or reducing sugars in urine and protein. So there can be also bilirubin in urine. So what is the color of urine when a person is having jaundice? Yellow. Dark what? Deep yellow, or it is dark, somewhat reddish in color. So, okay. So these are the chemical constituents. Then we can see the bacteria under the microscope after staining, or we can see some casts. Cast means it can be formed of WBC, RBC, or it can be formed of the epithelial cells which are lining the nephron. There are some proteins called TAM Horsfall proteins. They also form some casts. So I will show you pictures. So you don't have to know in detail, just here these things can be present in urine. And growing of this pathogen is called culture. So these are the characteristics we have already read: color, odor, specific gravity, pH, and these are the things which have to determine if it is present or absent. Protein, glucose or reducing sugars, ketone bodies, WBC, RBC, and casts. So what is the normal volume of urine per day? It is around 1 point. Okay, it is around 1 to 2 liters. So what is polyuria? More than 2.5 liter. What is oliguria? Less than 300 ml. কোন বইয়ে পেয়েছো? স্যার লিখিয়েছেন। কিছু কিছু বইয়ে লেখা আছে 500 ml, কিছু কিছু বইয়ে লেখা আছে আবার 400 ml. So all the values are right. Then anuria. Anuria generally mean no urine. But in practical sense, it is less than 200 ml or very little urine, almost no urine. And nocturia, when the person is getting up at night to pass urine, but the volume should be more than 500 ml. That is nocturia. So what are the causes of polyuria? Diabetes mellitus, diabetes insipidus. Anything else? What? Diuretics. So what are diuretics? Any drug that is increasing the volume or output of urine. And can you tell me any physiological condition in which you may have polyuria? What? If the person is in shock, how can he or she pass urine? Shock মানে কি? বাংলা বোঝো তো? When the person is having severe blood loss, then the person can go into shock. So when there is less blood in our body, so the person cannot pass more urine. So that is a condition in which there will be oliguria or less urine production. So if you drink too much water, so if I ask you to drink 5 liters of water in half an hour and then come back, so after sitting in the class for 10 minutes, you will say, I have to go to the toilet. So you have to pass a lot of urine to maintain your blood volume. So if you drink too much water, you have to pass out too much water. So that is a physiological condition in which there can be polyuria. So oliguria. So it can be due to what? Okay, that is also a cause. Anything else? What? prostate enlargement. Kidney failure. But prostate enlargement, the person will not pass urine because he may suffer from pain. But where is the location of prostate? Do you know? হ্যাঁ, এরম দেখালে তো হবে না, মুখে কিছু এক্সপ্রেস করতে হবে। So I said that the ureter is coming out from the kidney. It is coming into the urinary bladder, and from urinary bladder the urethra is bringing the urine out from our body. So in between the urinary bladder and the urethra, so at the lower part of the urinary bladder, if you see the picture, so there is a structure called prostate. So if that becomes big, so what will happen? Through inside that prostate, the urethra is passing. So if that becomes big, it will constrict the urethra. So that's why you may say that the person is passing less urine. Because he may be suffering from pain, that's why he wants to pass less urine. But the oliguria, we generally mean the urine is formed less, or much concentrated urine is being formed. So that can be due to what is renal ischemia? When less blood is coming to the urine. So urine is formed from blood. When less blood is coming to the urine, there will be less urine formation. Acute tubular necrosis, that is a kind of kidney disease. Obstruction of the urinary tract, what she said. The prostate, if it gets enlarged, the person will pass less urine. And acute renal failure, that is also kidney failure. So acidic urine, there are some conditions in which the urine becomes acidic or more acidic than normal. So it can be due to diabetes, starvation, and fever. So in starvation also the ketone bodies increases. So that's why here it is written ketosis. So there is a condition in diabetes called diabetic ketoacidosis. So what happens in diabetes? Can anyone tell me? No, diabetes mellitus. So what many people have, you be knowing, there are so many people that have diabetes mellitus. So what is the problem they are suffering? There is a problem with insulin. So there is a problem with insulin. So what that leads to? Increase in the blood glucose level. But the body is unable to utilize the blood glucose. There is too much glucose or blood sugar. But the body, the other cells cannot take the glucose from the blood and utilize. Because there is some defect in the either production of insulin or how the insulin acts. So there can be defect in the receptors of insulin in diabetes. So next it is systemic acidosis. So there can be many causes. There can be metabolic causes, respiratory causes of systemic acidosis. What is UTI? Urination. So some bacteria or pathogen can cause acidic urine, and some pathogens can also cause basic urine. So here E. coli can cause acidic urine. And then there are some acidification therapy. Then alkaline urine. So it can be due to strict vegetarian diet, or infection with some bacteria like Proteus, systemic alkalosis. It can be also due to metabolic causes or respiratory causes. Alkalization therapy. So high specific gravity. This can be due to oliguria. So what is happening in oliguria? Less urine. So the person is passing less urine but concentrated urine. Low specific gravity. So what will happen? The person will pass more urine. So there, when the kidney is failing, so what will happen? The urine will neither be concentrated nor be diluted. So the kidney will always pass the urine at a specific gravity, at a fixed specific gravity. So this is called isosthenuria. So we can detect the different abnormal constituents of urine by some tests with the help of strip. So these are the plastic or paper strips on which certain chemical reagents are added. So when we dip this strip in urine, the color of these chemicals change. And after we dry this strip, we have to match the color with the given chart on this bottle or provided by the company, so that we can understand which ingredient can be present. বোঝা গেল? So this is the chart and this is the strip. We have to match these colors to identify what is the, so here it is written pH. So if we match the color of the strip here with this, then we can find what pH the urine is. Sometimes we just give reports like this about protein or glucose. When it is negative, there is no protein. When there is very little amount of protein, it can be positive or negative. When there is very little amount of protein, but we are sure that this is the protein, then it is 1 plus. And when there is a huge amount of protein, it is very heavy, or we use several plus signs. So urine culture. So here we can see this is urine. So what is this thing? Petri dish. So this is a container in which we can put culture medium. So in this Petri dish here, we are putting blood agar. So blood agar is a culture media. So here this is red, this is blood agar. So now if we put this urine on this blood agar, if there is bacteria in this urine, it will grow. So after we keep it for some days at ideal temperature, these are the colonies of bacteria. Here we can see the whitish things. There are also small white dots. This means from a single bacteria, it has grown to tens and thousands and lakhs of cells, so that we can see them in naked eye without microscope. This we can see. So here also we can see these are the colonies. So what we will do, this is called loop. So this is a metal wire. So we will put this upper part of the wire on this colony and take a slight white part and then put it on the slide, then stain it, and then we can see it under microscope. There are different kinds of stain to see the bacteria. So these are the casts, what I was saying. So you don't have to know, but these are the casts. There can be some things called cast in the urine. So if they are made up of RBCs, these are called RBC cast. So there is a disease of kidney called glomerulonephritis. If they are made up of WBC, they are called WBC cast. These are also some diseases of kidney. It can be also formed of protein called hyaline cast. So what is the name of the protein? I said earlier, TAM phosphol mucoprotein. So this produces hyaline cast. So if there are too many fat bodies or fat in the cast, it is called fatty cast. So if the cast is granular, or you can see granules under the microscope. So these are, here we can see granular cast. And if the cast have epithelial cells, then it is called renal tubular epithelial cast. So just remember, there are something called cast. Okay. Then we come to from here start writing. What are the chemical things we try to identify in the urine? We have already said the glucose is coming into the Bowman's capsule and then it is getting absorbed back, that is reabsorbed in the proximal convoluted tubule. So there is a certain rate or speed by which the tubular epithelial cells is absorbing the glucose. So this is called tubular reabsorption, or the maximum rate is called tubular maximum for glucose. In some books it is also written 375 milligram per minute. So when there is per minute, it is the speed at which the glucose is getting absorbed back into the peritubular capillaries by the tubular epithelial cells. So what is renal threshold for glucose? When the glucose level is more than 180 milligram per dl, the proximal convoluted tubule cannot absorb all the glucose back and send it back to the peritubular capillaries. So if the glucose level is more than 180 milligram per dl, it will be excreted through the urine. So this is called the renal threshold for glucose, this value. So when there is glucose present in urine, it is called glycosuria. And the test we utilize for detecting reducing sugars in urine is called Benedict's test. You will be supplied with urine. Then we will take a test tube and take 5 ml of Benedict's reagent. Then on this reagent we will add 8 drops of urine. And then we will heat it. So the color of Benedict's reagent is blue. If that changes, if the color changes, then we have reducing sugar in the urine. So it can change to different colors like green, yellow, orange or red. So depending on the color, we can more or less say what amount of sugar that can be present in the urine. So with this Benedict's test, we can identify whether glucose or reducing sugar is present or absent, and we can also estimate what is the approximate amount of that reducing sugar present. So that's why it is called semi-quantitative. So there are two kinds of tests. One is quantitative and another is qualitative. So in qualitative, we just estimate whether something is present or not. So in the urine, whether glucose present or not. That is qualitative test for urine. And quantitative, we can estimate what is the level of this reducing sugar in urine. But we cannot exactly specify that in this urine, the sugar is 0.5 gram percent. So that will be specific. So we will generally give a range. So you have to remember the ingredients or composition of Benedict's reagent. So here we can see on the left corner sodium citrate, sodium carbonate and copper sulfate. These are present in Benedict's reagent. And they have different functions. So sodium citrate, it prevents precipitation of cupric hydroxide. Sodium carbonate, it provides an alkaline medium. Copper sulfate, it supplies the copper ions. And these cupric ions, when converted to cuprous, they will lead to the production of the color, sugars. So here, lactose, galactose, fructose, pentose. So they are sugar, protein or lipid. They are all sugar. Homogentisic acid, creatinine, ascorbic acid, salicylic acid. What are these? Acids, okay. But that is determined by pH. So other than this pH property, what are they? So this homogentisic acid, this is produced during amino acid metabolism. So creatinine, it is produced from something called creatine or creatine phosphate that is found in the muscles. Ascorbic acid, what is the other name of ascorbic acid? Vitamin C. And there is another thing, salicylic acid. So they are also giving this test positive, but they are not reducing sugars. So you have to remember these things. So these are the conditions when you will find sugar in urine. It can be from hyperglycemic glycosuria. So the sugar level in our blood has increased. So that's why the sugar is coming out through the urine. Write it down. So one is when the sugar level in our blood has increased, the sugar can come out through the urine. But in some conditions, when even the sugar level in the blood is normal, then also the sugar can come out in the urine. So where is the defect? So first I said that when the blood is getting filtered, all the amino acids, sugar, they are coming within the Bowman's capsule and they are getting reabsorbed back in the proximal convoluted tubule. So if there is any defect in this reabsorption in the proximal convoluted tubule, the sugar will not get absorbed back So the sugar will pass on with the formation of urine and will be given out in the urine. So this is due to renal glycosuria, or there is defect in the reabsorption, glucose reabsorption. লেখা হয়ে গেছে? Okay, now we come to protein. So the first test, what we do is heat and acetic acid test. So we will take a test tube, we will fill the test tube up to 2/3 or 3/4 and heat the upper part of the test tube or the upper part of the urine in the test tube and see whether there is appearance of any cloudiness or not. The upper part of the urine and see whether there is appearance of any haziness or whitish cloudiness. So why we are not hitting the lower part of the urine in the test tube? I am asking you to hit the upper part by holding the test tube in a slanted fashion. Lower part is the control. So what do you mean by control? So if there is very slight difference of the lower part and the upper part, we can differentiate in the same test tube. So if there is very little whiteness or cloudiness in the upper part, we can right away compare the upper and lower part. So that's why we are keeping the lower part as control. That's why we are hitting the upper part. So then we are adding acetic acid. So what is the role of acetic acid here? If there is protein present with the addition of acetic acid, it can intensify. But if the cloudiness or whitish appearance is due to carbonate or phosphate, it will become less cloudy. The intensity will reduce. So there are many causes of proteinuria. So we generally, for our own understanding, we differentiate it into, not differentiate, we classify it into pre-renal causes, renal causes and post-renal causes. So any causes which are occurring before the blood is entering into the kidney, these are pre-renal causes. If there is defect in the kidney and due to that defect the protein is coming in the urine, those are renal causes. And if there are any damage in the urinary tract and urine is having protein, then it is due to post-renal causes. So here in pre-renal causes, we can see heavy exercise, fever, hypertension. There is a disease called multiple myeloma, eclampsia. These can cause increased protein in urine. So what is eclampsia? Or what is multiple myeloma? What? So what is Baines-Jones protein? Oh, this is very good that you said that there is something called Baines-Jones protein which is found in multiple myeloma. So the immunoglobulins, what are immunoglobulins? They provide us with the defense of our body. So these immunoglobulins are produced by some cells. So can anyone tell me which are those cells? They are present in our blood. What? B cell. So B lymphocytes. So B lymphocytes produces some cells called plasma cells. These plasma cells produces immunoglobulins. So this multiple myeloma is a cancer or malignancy of these plasma cells. So what will happen? What is malignancy? In malignancy, the power of the normal cells to control the cell division is lost. So the cells multiply, in malignancy the cells multiply in uncontrolled manner. So when these cells, these plasma cells, have this malignancy, multiple myeloma, they produce huge amount of immunoglobulins. So what I said, what is the function of immunoglobulin? Defensing mechanism or immunity of our body. So if there is too much immunoglobulins in our body, so our immunity will be strong or less strong in this disease. Did you get my question? Did you understand my question? কে বললো yes? yes কে বললো? তাহলে কেউই বুঝতে পারছো না। কোয়েশ্চেনটা বুঝতে পারলে না? I am saying that these plasma cells produces immunoglobulins. And immunoglobulins helps us with our defensive mechanism, that is immunity. So now I am saying in this disease, multiple myeloma, this is a cancer or malignancy of these plasma cells. And due to this malignancy or cancer of these cells, these plasma cells are producing huge amount of immunoglobulins. So our immunity or defensive mechanism will become more prominent or less? Less কে বলছো? আর more কে বলছো? Less. তো reason দাও।
Because you produce autoantibodies against
Autoimmunity is different.
autoantibodies.
Autoantibodies is produced in autoimmunity, the diseases, but that is different. I am not saying autoimmune disease. I am saying this is a malignancy or cancer, what we generally call. So because these are malignant cells which are producing these immunoglobulins, they are not normal. Normal immunoglobulins helps in our defensive mechanism. But if they are produced by malignant cells, they are not normal. So that's why even if the immunoglobulins are more, our defensive mechanism is not getting stronger. It is getting weaker. Slide লেখা হয়েছে? Write it down. This is due to damage or some kind of disease of the kidney. And in postrenal, this is due to damage of the urinary tract. Okay, so microalbuminuria. So microalbuminuria, this is something when very small amount of albumin is present in the urine. And you have to remember the range, it is around from 30 to 300 here it is written, 30 milligram to 300 milligram per day. If this amount of protein or albumin is present in the urine, this is called microalbuminuria. And why it is important? It helps us to diagnose some of the diseases. Not exactly to diagnose, to understand that this disease is going to happen, or there is more risk of those diseases. And this, the level of albumin, protein produced by microalbuminuria cannot be detected by urine dipstick. So what is this? That what I showed previously. Those strips which are impregnated or attached with different chemicals for diagnosing different constituents of the blood, of the urine. Because the level is low, we have to utilize lab test. Those strips cannot detect. That doesn't mean we cannot detect. So here, if we take blood in a tube and then spin it in a centrifuge machine, just rotate the blood in a machine, then this upper part is called plasma. Then there is a whitish part that is due to WBC and platelets, and then the red part that is due to RBC. So there are some proteins, some very important proteins, that those are found in plasma. Can you tell the name of any one of them? Albumin, then globulin, fibrinogen. So these are some of the important proteins that are found in blood or plasma. So if we do electrophoresis, we can separate these proteins. So here we can see, after electrophoresis, this is a process in which we can separate proteins. So here there is albumin and the other protein is globulin. So there can be different types of globulin, alpha, beta, gamma. So the immunoglobulins, they are gamma globulins. So what I was saying about multiple myeloma, the gamma globulins. So here in multiple myeloma, we find a protein called Baines-Jones protein. So this we also detect similarly as we perform the test for other proteins. We will take the urine, heat it, and there will be cloudiness. But after a certain point, when we start boiling the urine, then the cloudiness will disappear. And this characteristic is specific for this Baines-Jones protein. And again, when we will cool down the urine, the cloudiness will reappear. So we will see the cloudiness at around 40 to 60 degrees Celsius. Then it will dissolve at around 100. And then when we will cool down the urine back, then it will again reappear. So this is specific for Baines-Jones protein. So this is another test we utilize for protein, Heller's test. Nitric acid, and then we are adding urine above the nitric acid. So what will happen? The two liquids will come in contact, and there will be a whitish ring or precipitate between the junction of the two liquids, the nitric acid and the urine. And this whitish ring, that is due to denaturation of protein. So what is denaturation of protein? দাঁড়িয়ে বলো। So the other than the primary structure, the protein loses, like secondary structure, tertiary structure. If the protein has quaternary structure, all will be lost. Only the primary structure of protein will be maintained in denaturation of protein. বোঝা গেল? So this is the last test, sulfosalicylic acid test. In sulfosalicylic acid test, we are taking the urine and adding a few drops of this sulfosalicylic acid. And there also we will see some precipitate or whitish discoloration.